Okay, so this is from Spring 2020 exam number 2, problem number 1. So we have a motor that applies a constant downward force F, so I know that this is pulling this cable in. If that cable's going in, this is probably going up, and as this goes up, this is going down, okay? It has a downward force of 1,600 pounds. It's raising a 6,500 pound elevator. The counterweight is 3,800 pounds. The elevator starts from rest. After the elevator travels 40 feet, determine all of these things. So the first thing I need to recognize, number 1, is I have cables. And if I have cables, I'm going to need to get my ratios of, of each side of what's connected. So the ratio of this, the motor, and this dot C coming in, and its relationship to E moving up. Remember, that's the beauty of cables, okay? And I know that we're pulling down at 1,600 pounds, and this is a 6,500 pound elevator, and my counterweight is 3,800 pounds. So I'm going to make sure I draw free body diagrams, because I also, if I have 1,600 pounds in this cable, I've got tension, and if this thing is moving, I've got to figure out free body diagrams for each of my little systems in place here, okay? So the first thing I'm going to do is I'm going to call this one length 1 and this one length 2. Okay, so starting with length 1, I'm going to draw a datum, and I can come down to that point. And it doesn't matter, I could put my point down here, I could put it way up here, it doesn't matter. We're just looking at relationships. So I have delta C plus, I'm going to come around, and it doesn't matter, this is constant, so we can just call all of these delta E. And then I'm going to look at my weight. Again, it doesn't matter, delta weight. So I have delta elevator, delta motor, or point C, and delta weight. So I have delta C plus, I'm going to go up, and maybe I'll get a colored pencil for this. So I'm going to go up, so there's a delta C, here's a delta E, and a delta E. So I have delta C plus 2 delta elevators equals the whole length of my rope. And again, I don't care how long that rope is. I'm trying to find this relationship. So I know that as my position C moves, my elevator is also moving, and it's negative because it's moving in the opposite direction. So as C moves down, my elevator is moving up. Okay? And we could rewrite this where we could say, well, my position of my elevator is negative position of my dot C going to the motor divided by 2. So that tells me that that this is moving, okay, twice what E is moving. And again, that's the beauty of our pulley systems. Okay, I also know then that my velocity of C is -2 velocity of E, and the negative just means going opposite direction. Acceleration of C is -2 acceleration of E. So I have this relationship between point C and my elevator. And now I need to look at cable 2. And cable 2, we can start here, and I'm going to go up a length E. So I have length E. And as I come around, shrink, I have plus length W. And you should already notice this is a 1-to-1 ratio, and it's going to be negative because one's going up and one's coming down. And again, this is going to be my entire length of my rope, but we don't really care about that. So we can really say that as my elevator is moving, my weight is moving, and they're a 1-to-1 ratio. But that makes sense. It's just rink, rink, rink. Okay, so if I wanted to know anything about the weight moving with respect to the motor, the weight and the motor, then E, my elevator, is that piece that connects them both. So I could say, well, if E equals SC over 2 and E equals negative SW, then I could set SE equal to SE, and I would get negative SC over 2 equals negative weight. So the weight equals over 2, which, let's see, does that make sense? They're both moving down, so they should be the same positive, negative. And this is a 1-to-1 ratio with the elevator, so it makes sense it's also a 1-to-1 ratio with the motor. Okay? So because I have this relationship here, then I know that the velocity of E equals negative the velocity of the weight. And again, the negative is just describing the direction. So we want to find the tension. So now I've got my cables taken care of, because when I see cables, I've got to take care of cables. Now what I'm going to do is set up a free body diagram. So if I look at my elevator here, I notice that I'm going to have tension coming from the weight. And I have this nice little pulley here, boink. So I'm going to have tension from point C. Okay, so this is my elevator, and it has a weight of 6,500 pounds. Okay, so 6,500 pounds TC. Now let's come over here and draw a free body diagram of my cable. If I have 1,600 pounds pulling down, then my cable has to be pulling up, equal and opposite. So I can see that TC is 1,600 pounds, which means this is 1,600 pounds and this is 1,600 pounds. Okay, now I'm going to come over here, and it's moving up, so it's going to have an acceleration in the y direction, a velocity in the y direction, and if we're moving, we cannot say that the sum of the forces equals 0. Okay, we just can't say that. I'm also going to have this weight, and this counterweight is 3,800 pounds. And there is a tension in this cable, TW. We are also moving, so we have acceleration and velocity in the y direction. So when we sum our forces, sorry, let me turn that off. Okay, when we sum our forces then in the y direction, I have to take into account that we have acceleration in the y direction. And when I sum these forces in the y direction, I have to take into account we are actually moving. So I have to remember to put these y's in there. And because this relationship is a 1-to-1 ratio, as this is moving, I know that this acceleration in the y direction has to equal this acceleration in the y direction. Because we found up here that our velocities and our accelerations and our position change is a 1-to-1 ratio. Okay? So now what I need to do is start setting up my knowns and my unknowns and figuring out where I'm headed. Okay, so I am looking here, and so now I'm going to, okay, if I know forces, I could go back and say that we were traveling 40 feet. But everything's moving. I don't want to deal with force distance. But I could work this where I'm doing force distance and I find my velocities, because I do need to find velocities. Okay, or so I could do 1/2 mv squared plus, okay, because I know all of this stuff. I could try starting there, or I can sum my forces equals mass acceleration. Okay, and I'm just going to go with that method because there's less stuff in an equation. So if I look at my elevator, okay, if I'm going to sum forces in the y direction, and this is of my elevator, then I'm going to have equals mass times acceleration in the y. I'm going to have 1,600 pounds times 2 plus the tension going to the weight, okay, minus 6,500 equals mass, so 6,500 over 32.2 acceleration in the y direction. And I can look at this counterweight. And if I sum forces in the y direction, I know they have to equal mass acceleration because we're moving. So I'm going to have TW, that's tension in the weight cable, which matches this one, minus 3,800, okay, equals mass. So if I'm in pounds, this is a force. So to make a force a mass, we divide by gravity times AY. And so when I look at this, I realize I have, what do I have? I have one equation and I have two unknowns. I have two equations and I have two unknowns, okay? But the thing I need to take into account is if we're just going to, if we know that these are both a y, and really what I should have done is called this AE, A of the elevator and A of the weight. So let's go back and do that. A of the elevator and A of the weight. A of the elevator, A of the weight. So it looks like I have 1, 2, 3 unknowns. But I know that the acceleration of the elevator equals negative acceleration of the weight. So I can just substitute and just call it AY. So this one is a positive AY. And if this one is positive, make a giant A, then this one has to be a negative AY because they're going in opposite directions. Okay? So I have the acceleration of the elevator, the acceleration of the weight. I know that they are equivalent, but opposite. So I can just call them AY. But I'm going to have to make sure that I'm noting that one of them is positive. And I'm going to have to make sure that I'm understanding that one of them is actually negative. Okay? So now we need to do some math work. And I'm trying to find a blank sheet of paper, which I know I have plenty of. Okay, so we have 2 times 1,600 pounds plus TW minus 6,500 equals 6,500 over 32.2 A. And we have, where's the other one? TW minus 3,800 equals 3,800 divided by 32.2 times negative A. Okay? So I'm going to have to rewrite in terms of one or the other. So let's just take this TW and write it equation 1, 2. So TW equals 3,800 plus, actually we're going to make that a minus 3,800 over 32.2 A. And then we're going to plug that up into equation 1. So we now have 2 times 1,600 plus 3,800 minus 3,800 over 32.2A, okay, minus 6,500 equals 6,500 over 32.2A. So we need to get all of our A's onto one side. So let me find my calculator. So I have 2 times 1,600, so this is 3,200, plus 3,800 minus 3,800, enter 32.2 divided by, that's a big number. We're just going to keep it, I'm not going to simplify that yet. Okay, so now I can add, I've got 3,200, enter. I've got 3,800 plus, okay, 3,200, enter, 3,800 plus, and I get 7,000 minus 6,500, and I get a 500, and I'm going to bring this one over, so I have 6,500 over 32.2A plus 3,800 over 32.2A, 6,500, 32.2 divided by 3,800, 32.2 divided by, and I can add those together, and I get 319.876A is 500, and now I can divide, and I get my acceleration is 1.563, okay? So that is 1.563, and I am working in, gravity is feet per second squared, so this has to be feet per second squared. So this is the acceleration that I can then use to continue with the rest of my problem. And I know that this is for the acceleration of the elevator, which is going down, and for that counterweight, which is going up, which would be the negative value. Okay, so we now have this. So if I'm looking at question B, it says the acceleration of the counterweight. So the acceleration of the weight is going to be 1.563 negative feet per second squared. C says the acceleration of the elevator, 1.563 feet per second squared. So that's going up. We could take that away and just say that's going down. Use magnitudes and direction. And now it says the velocity. Okay, it's wanting the velocity of the counterweight. Well, I know that my counterweight has, so this is D, I know that my counterweight has an acceleration of 1.563 feet per second squared. I also know, I'm going to have to go back and look, but it says the counterweight, the elevator travels 40 feet. So if my elevator is traveling up 40 feet, and I'm looking at this relationship of the elevator and the counterweight, I know that the counterweight is traveling down 40 feet, okay, because it is a 1-to-1 ratio, okay, 1-to-1 ratio. So I know the distance is 40 feet, and it's asking me for velocity. We were starting at rest, so I have constant acceleration. We are starting from rest, okay? So I can say that V squared equals V naught squared plus 2AS final minus S initial. So my velocity squared is, well, we started at 0 plus 2 times 1.563 feet per second squared, and I am moving down, we're going to call down positive, I'm moving down 40 feet. So when I do my math here, I have to enter 1.563 times 40 times, I get 125.04, and when I square root, okay, when I take the square root of that, I get 11.18 feet per second. Okay, 11.18 feet per second. And we are going down. So this is the velocity of the weight. And if I know the velocity of the weight is 11.18, then I know the velocity of the elevator is also 11.18 feet per second. And that's going up. Okay, and then it says the velocity of point C. Well, I have to go back to my relationship, and my relationship is that the position change, or the velocity, sorry, you can't see that, the velocity, okay, the velocity of the elevator equals negative velocity C divided by 2. So the velocity of C is negative 2 times velocity of elevator. So that means the velocity of C is negative 2 times the velocity of the elevator. Okay. And 2 times, I get 22.36. It's negative, so I know the velocity of C is 22.36 feet per second, and it is going down because it was negative. Okay. And so this is just, I would expect a pulley type problem, because it's just, you need to have this understanding of the system. But again, this is the beauty of a pulley system, is that it increases that force that's in our system. So I went from 1600, and by doubling it, I now have 3200. So I've doubled that force provided by my motor. I've also decreased the velocity of this point in half, so that I'm not like shaking up the people inside of an elevator. Okay, so that is how you would set up a pulley problem. This is a huge step right here. Draw this and remind yourself that you're moving.